So, students, welcome to this live session, which has been conducted for the course Theory of Production Process. As you know that this course comprises of three sections. One is casting, another is farming, and the last portion is welding. So, in the casting, we have talked about 4 weeks, and we have talked about the casting processes. We talked about the solidification involved, getting design, riser design, defects. These are mainly the topics which have been covered. You know that casting is said to be mother of the manufacturing processes. Casting involves conversion of metal into different shapes, maybe conversion from liquid to solid state. And when we talk about metals being transformed to a particular shape, then certainly that since it's solid and it has higher melting point than room temperature, so it is normally in solid state. So to bring it into any shape, you need to have the fluidity into it, and that's why it is heated and melted in an external pot, that is normally furnace, using the furnace, and you have so there the facility to melt. Maybe melting is done to ores and many other scrap materials also. So depending upon the requirement, we also do the necessary refining processes, or we keep it clean from the foreign substances. Then further, this melt is going into a cavity, because in casting, although we are having a shape, but that shape we are getting in one go itself. That is the difference between a cast specimen and a fabricated specimen normally, like either by machining or by forming. So in casting, you are getting in one go itself. So you are having the metal in the melted state. This molten metal is poured in a mold, and that mold is normally made of ceramic material, mainly the sand. But the mold may be made of other materials, especially metals of higher melting points, and even molds are made of other metals also, cast iron, or there may be anything depending upon the metal being cast. Now, when we are using normally the ceramic based material, maybe sand or most of the this is the most versatile way the sand is being used as the molding material, because it has many advantages over other molding materials. Like it is cheaper, it is abundantly available. The heat transfer rate through the mold wall and through the mold is of moderate value. So that's why you prefer. But then, if you want to have better properties, if you want to have the production on mass scale, then certainly you need to have the process in which you can use the mold many a times. So sand mold is normally one time used, single use molds, while you have other material cases. In many cases, we are using the metal as the mold. So they are basically used multiple times. So you have molding materials of different type. When we talk about sand molding, then certainly you need to have the binding among the sand particles, and also it should have many other properties. So that property has been discussed, that what are the qualities of those sand particles which are used as molding material. So normally you need to have refractoriness because it is being subjected to, uh, because it is in contact with the metal at very high temperature. So there is a chance that it may burn or it may fuse. So it should have that property to withstand that high temperature, and that property is fusion, refractoriness in fact. So apart from refractoriness, you have many other properties that the sand must have. Permeability, mold, I mean sand mold should have. So that is permeability. You have hot strength, you have green strength, dry strength. So this has been discussed already in the slide in the lecture. Further, there has been talked about the solidification process. So how the solidification starts, from where it will start in the casting cavity and where it will end. So normally it will start from the sides where the undercooling is maximum, because once there is undercooling at any point, then there will be and that will be a driving force for the phase transfer from liquid to solid state. So, depending upon where the undercooling is preferably there and where it should start and where it should end, there has been also talk about the type or the way the solidification proceeds. So we know that it is normally the birth of new nuclei once the temperature goes down the solidification temperature. So below that temperature, by the mechanism of nucleation and growth, your solid metal is formed. Okay, and then it is normally for metals or materials with single uh, melting point, unique melting point. Whereas when there is a varying solidification range, in that case, your solidification mode is different. Solidification, because you have solid as well as liquid. So there will be a range of temperature during which the solidification will proceed. Okay, and in that, basically, there is a mechanism known as constitutional supercooling that occurs because you have solute and solvent is there, solute and concentration because of the variation of concentration of solute in the liquid metal at different times. So basically, you have a chance appearing where it is seen that if the cooling rate is below certain value, then that may lead to the formation of dendritic arm spacing or dendritic phases. So these things have been discussed in the solidification part. Further, we went to the different molding methods and molding machines, like what are the different machines or tools which has been used. So you have different tools like the pins are there, you have molding boxes are there, chins, chaplets are there. So these are the components and it has specific job to do during the molding process. Further, we talked about different type of, once we do the molding, then you need many things like you need core making. So cores are also made of, normally made of the sand particles itself. But then for core, the sand has to be different. That is core sand. So core sand, what should the qualities of the core sand? That you should know. Okay. Further, we have gone to different type of processes. Before that, we talked about the gating and the rising design. So gating and rising, as you know, gating network is there. Through that network, the molten metal flows from coating basin to the cavity. And the risering network is basically riser system will be ensuring that when you need the extra metal in case of shrinkage, because when there is conversion of metal from liquid to solid state, then the density is increasing, so that leads to volumetric decrease, and that is volumetric contraction, and that's what is commonly known as shrinkage of metal. So the shrinkage will be there, and that needs to be compensated. And for that, you have extra metal in the extra reservoir, that is riser. Okay, so riser's primary job is that, and in many cases when you use top riser, so it will also acting in many cases it will be the top riser will also act as the pouring basin itself kind of thing. So that through that the metal will go, and then it will be the last part to solidify. So riser system design talks about the design of the part or shape because of which it will be able to supply the liquid metal till the metallic cavity is solidified. And for that you have many kind of designs. So you have Keynes method, shape factor method, and all that modulus. So there are all these methods are used to see that what kind of riser is required and what shape of riser is best, so that it can work better for the casting process. So in the risering design we talked about it. Then we moved to gating system design. And in getting system design, normally we talk about the network, getting system overall. And in that, we talk about other processes like controlling the solid, turbulence, and the way to filter out the impurities. So all these things are there in the gating system. We have top gating, bottom gating, and pattern line gating. So that variety has been told. Then you went to the different type of processes you can go through the different processes of casting, hot chamber, the cold chamber, centrifugal. A lot of casting processes are there that we discussed. And finally, we talked about also defect. So what are the normal defects which are likely to appear in the casting process, and how they can be circumvented, or how they can be it can be ensured that the defect occurring chance is less. So this is mostly the part which is covered in the casting section. Apart from the casting section, we will have the welding section as well as the forming section, and we'll talk about it in a while. In between, if you have any query, please let me know. Next, we are going to have some discussion on the forming part. So, as you know that in forming, we apply the forces on the specimen to deform it to different shapes. Uh, Forming may be done at either the lower temperature side, that is cold working or cold forming, and to a higher side where there is a temperature which demarcates them, that is recrystallization temperature. So that will be called as hot working temperature. And as you know that when we talk about forming, we are talking about that zone in which there is plastic deformation. So the material going to go is plastic deformation, and the deformation is permanent. Otherwise, you can have the pressure applied, but it will further regain to its shape once the load is removed if the material is in the elastic range. Deformation is in the elastic range. So that way, in that forming, we talked about forming processes. I talked about stresses which are involved, talked about stress types, deviatory and mean stresses. Then, you have the failure equations. You have different equations like Tresca criteria is there, Tresca hormesis criteria is there. Then in forming, we talked about the different forming processes, the defects, and the deviations for finding the forming loads, forming defects are there. So those aspects have been covered in the forming. We also talked about the different kind of defects which we encounter in rolling or forming. You know, rolling in rolling you have the rolls both the sides, and the material goes in between the rolls, and cross section area is reduced. So reduction in cross section area is formed. So you have rolling, forging, then you have other processes like wire drawing, tube drawing. So all these are processes have been discussed in detail in different chapters. Last section is related to welding, and in welding we talked about the the need for welding, the setup for welding, what are the terminologies which are involved in typical welding processes, and we talked about the mechanism of the gas welding or the arc welding. So in gas welding, certainly you lose the chemical energy. So the hydrocarbon based gas is used to ignite and with the help of oxygen, so it gives a flame. Otherwise, in arc welding, we produce the arc by striking the electrode from another electrode, that is workpiece. So you have the formation of you know arc, and that arc is ionized gas plasma, so that has a lot of temperature, high temperature, and instantly it melts the metal. So that way, in welding we talk about the different polarities in the case of DC welding. Then we talk about soldering, brazing, and especially the gas acetylene welding. We talk about the arc welding and different arc welding processes. Somewhat in brief detail we have talked, and then ultimately welding defects. So this is mainly the content of the course what we discuss, and finally I would like to see that if there is any query, and if there is the query from side, I will be very happy to explain that. And I will wait for another minutes, or few minutes, 5 to 10 minutes, and then if there's no query, then maybe I will try to uh, disconnect, and wish you a good luck to appear in the exam and do better. Thank you very much.